Okay, so here is our first um, video recorded lecture to begin the lecture material for Chapter 2. So Chapter 2 is going to be about the chemistry that is behind the biology that we're going to spend the rest of the semester talking about. So to really understand biology, we have to back up a step and talk about the chemistry that is behind it. Understanding atoms and molecules and bonds will help us to understand how molecules interact, how we get energy from them, and how living things utilize those materials. So we're going to spend the first couple lectures talking about chemistry. To really understand chemistry, we have to back it up a little bit and talk about physics. So physics explains how the molecules in chemistry interact, which then explains the biological systems in living things. So if we look at physics, we can look at how everything that we have on this planet or outside of this planet would be considered matter. And the definition of matter is anything that occupies space and has mass. Mass is the amount of something of matter inside of an object. It is not the weight. Weight is dependent on gravity. Mass is not. So mass of an object doesn't change regardless of whether or not it's on the earth or it's on the moon. The weight would change, but the mass would always be the same. Here on Earth, we find matter in three different physical states. We have solid, liquid, and gas. There are other phases of matter that are formed naturally, but they're just not found here on Earth. For example, plasma is a form of matter that is found on the sun. So that's a natural form, it's just not found here on Earth. So we're going to focus a lot on the concepts of solids, liquids, and gases. Elements are what make up, they're like the Legos that make up everything on our planet. And an element is defined as something that cannot be broken down into any other substance. There are 92 naturally occurring elements on the Earth. And these elements are found all over the Earth in many different forms. They can also be found outside of the Earth. So they've been found on planets, they've been found on moons, they've been found on asteroids, comets, but they are all natural. These first 92 elements on the periodic table are all naturally occurring here on the Earth. So these first 92 elements, as they were being discovered, they were organized into a system and that is known as the periodic table. Now, I'm not going to ask you to memorize the periodic table. I'm not going to ask you to memorize names or atomic symbols or mass numbers. But it's important that you understand the way that elements are put here on the table. It's not just random. So the elements that you see here are organized into families and into periods. And those families and periods have traits that link them all together so that they have similar characteristics if they're in the same family. We also see patterns of how elements are arranged on the table. So where an element is on the table tells us a lot of information based on its size, its electronegativity, how many valence electrons it has, lots and lots of information. We are going to be utilizing the periodic table to understand elements so that we can know the number of neutrons and protons and electrons and how those electrons are arranged into orbitals. But again, I'm not going to ask you to memorize them, but we will use the periodic table a lot, so we're going to have a lot of experience with trying to understand the periodic table. These are supposed to be funny. You should be laughing. If you look at the atomic symbol for sodium, it is Na. A lot of times the symbol does not match with the name of the element, and that's because it's Latin based. So sometimes they make sense, but other times they don't. Here's another example of one not making sense: mercury. So the atomic symbol for mercury is Hg. There's neither an H nor a G in the word mercury, but still, it is the atomic symbol. Mercury is very unique on the periodic table because it is the only metal that is liquid at room temperature. Here's another one that doesn't exactly match up name and atomic symbol. That's copper. And we have lead. So lead's element symbol is Pb, and this comes from the word plumb, and it was used in something called like a plumb bob that was made out of lead and used to determine the levelness of something that might be hanging vertically. So that's kind of where that Pb comes from. Potassium's element symbol is K. Helium's element symbol is He. And here's one of my faves. You can use this line if you ever need to, hanging out with your friends or seeing somebody you want to talk to. You can definitely borrow this one. You could tell whether or not they are a chemistry person on whether or not they understand the joke. Again, I said you do not need to memorize all of those elements that are on the periodic table. Some of them we will use a lot and you will just naturally get to know them, get to know their element symbol, get to know their name, maybe even their atomic number and atomic mass. We're going to focus on a small number of them because they're really important to living things. There are 25 elements from the periodic table that are really essential to life. Of those 25, 4 of them make up 96% of the human body. So we can kind of compare this to Legos. And there's kind of this general Lego shape and color that is usually in all these different Lego kits and used to build all these different Lego structures. That would be like these 4 elements here: oxygen, carbon, hydrogen, and nitrogen. These are the 4 main elements that make up all living things. So you're really kind of made of 4 basic Legos. And we can look at the arrangement of those Legos here. You see that 65% of the human body is made of oxygen with the atomic symbol of O. About 18.5% of the human body is made of carbon, which is the element C. Hydrogen makes up about 9.5% of the human body, which is an H, and nitrogen makes up a small amount of only 3.3%, and that has the element symbol of N. Now, if you look at this human picture here and you look at the feet represents some of the elements that are present but only in small amounts, and then the toes make up what we call trace elements. So if you look at the elements that make up the feet, you see calcium, phosphorus, potassium, sulfur, sodium, chlorine, and magnesium. Some of these you've probably heard of before, and they can be found in the foods you eat, like milk, or specifically in your vitamins. And you'll notice also that sodium and chloride are found in an exact percentage. That's because they're usually combined to form salt, sodium chloride. What's even more interesting are the trace elements. So all together, the trace elements make up less than 1/100% of the human body. Yet they can be very, very important. So if we look at some of these trace elements, we see boron, chromium. Chromium is where we get chrome, like on your bumper, same element. Cobalt, copper, the metal. Fluorine, iodine, iron, the metal. Manganese, molybdenum, selenium, silicon, like they used to make computer chips. Tin, the metal, vanadium, and zinc. These trace elements all together make up less than 1/100% of the human body. But that doesn't mean that they aren't extremely important. Let's look at one here in particular that is a trace element but is extremely important. Iodine. So iodine is one of these trace elements. The symbol is I, and it is very, very important to get iodine in your diet. A lack of iodine in your diet can lead to what's called a goiter. So this woman here has a goiter in her neck, and it has to do with her thyroid gland. So there are the thyroid gland produces certain types of hormones that have to do with your metabolism, and iodine is a very important component in producing those hormones. So if you don't have enough iodine in your diet, then the thyroid cannot do its job and it becomes very enlarged. In order to shrink down her goiter, she could have surgery. They also could give her certain hormone treatments that would stop the progression of the growth. It won't reduce the growth, but stop the progression. The only way to really remove that would be a surgical procedure. So I'm assuming that none of us listening to this would like to have a goiter like this woman has. So how do you avoid it? You make sure that you have enough iodine in your diet, which really for most Americans isn't a problem. The most common place that we find iodine in our diet is in salt. Now remember before I said that sodium and chloride together make up salt? There's no iodine in that chemical formula. A lot of the salts that we have are called iodized salt. So iodine is artificially added to that salt mixture or that salt compound, and it's called iodized salt. Now, what I don't want you to do is to run to McDonald's and get a bunch of French fries that have all that salt so that you don't end up having a goiter like this woman. There are other places, natural places, that you can get iodine in your diet. You can see here eggs, strawberry, and milk. These are all sources of iodine that you could naturally have in your diet to supplement the amounts of iodine in your system. Another way is you can go to a pharmacy and get liquid iodine, which is a brown color, and it's oftentimes used to sterilize an area. But you can put some of that iodine directly onto the skin, like at your wrist, for example, and your body will just naturally absorb it into the bloodstream, and that is an adequate source of iodine in your diet. You don't have to ingest it, but it's very important that you get enough iodine in your body. So this is Chemistry Cat. You're going to see Chemistry Cat a lot in our lectures because I think Chemistry Cat is hilarious. So this is showing that the element symbol for iron is Fe, lithium is Li, and neon is Ne. Hence the word feline. These elements on the periodic table can combine, just like Legos, they can combine together, two or more of them, to create a compound. It's very important though when you make a compound that that compound has a fixed ratio. For example, if we look at table salt, you have one sodium atom and one chloride atom together to make salt. It's always a 1-to-1 ratio. Otherwise, it's not salt, it's something else. We see the element symbol or the molecular formula for water, and you see that it is 2 hydrogens. That's what the subscript 2 means. After the H, it means 2 hydrogens for 1 oxygen. It always has to be in that ratio, H2O. If you alter that, if you alter the number of hydrogens or oxygens, then it's no longer water. For example, H2O2 is hydrogen peroxide. So adding one more oxygen to that water molecule causes it to change into a very, very different substance. This concludes the beginning part of our chapter 2, and we will finish the rest of this lecture beginning with information on an atom in class. See you then.